Hello, my dear warriors. Hi, Navya. Hello, Prem. Hello, PSK Paneer. Hello, Chandana. Welcome, Navya. Welcome, everyone. This is Captain Shreyas here, your physics master teacher on your favorite NEET English channel. Get ready for the most awaited session. That's transistors. So, some days back, I have done semiconductors where we have talked about diodes, PN junctions, what is P-type, what is N-type, and what is a semiconductor, its properties, the applications of diodes, right from LED to rectifiers and even logic gates. So if you have missed that session, please watch it. It is there on the channel itself. It's there in the playlist. I'm pretty sure many of you have attended it. And in case you have, just raise the hand or maybe put up a thumbs up so that I know you guys have seen that. So today's session is all about transistors. So I'm going to go right from the basics and I'm going to scale it up till the NEET level. So all those students who are preparing for the NEET examination, this session is going to be extremely useful for you. Okay, because we are going to see some questions as well as some theory aspects of transistors. Those of you who do not know me, my name is Shreyas and I'm your captain, your capto, your master teacher on this #1 English channel for NEET aspirants. And I have been training and guiding students for more than 12 years, and I'm very happy and I'm very proud to say this, that they are doing really well. And I know in the days to come, you are also going to make me very, very proud. So let's begin with the class by smashing the like button, which I am very good, and also hit the subscribe button so that you do not miss any of the sessions which are relevant to you for the NEET examination. Or else you might just lose the channel or you might just lose the flow. So stay tuned on the channel because you are going to have lots of classes on weekly basis from my side on this channel. So are you guys excited and ready to start? I had to prepone the class because I have to go to the doctor because one of my family member has to go to the doctor. So that's why I could not change the appointment. So that's why I have preponed the class to 6 o'clock. So let's begin. Now, do you remember what is P-type and N-type semiconductor? Semiconductor is nothing but any object or any body which has conductivity which is less than a conductor like copper and more than a resistor like wood. So it falls somewhere in between. Semiconductor, you can see the band gap between the valence band and the conduction band is very, very less. So the electrons can jump easily from the valence band to the conduction band. Once the electrons are in the conduction band, they can easily flow and conduct electricity. That's what it is. Now, in P-type and N-type, what happens in P-type? You create a vacancy which is called as a hole, which makes extra conduction. And in N-type, you add an impurity which creates an extra electron, which again increases the conductivity. Right? So P-type is formed using trivalent impurities. So there is a vacancy with the neighbors. So that vacancy is desperate. It wants to mingle around with other things. So that's why it calls other electrons towards it and it increases the conductivity. That is called as the hole. Electrons are extra in N-type, which has pentavalent impurity like phosphorus. That electron is eager to mingle with other holes. So that is the reason why the conductivity increases. So that was P-type and N-type semiconductors. We have seen PN junction, that is called as a, what is a PN junction called as? What is a PN junction called as, guys? That application, that device is called as a diode. Diode, the job was to allow the flow of the current only in one direction. This is just a quick revision of your PN junction, P-type, N-type, and what is a semiconductor. Very good, Mitra. Very good, Danush. Awesome, Pujita. Good evening, bacha log. So now, what will happen if instead of taking P and N-type, you take P, N, and P, or N, P, and N, you combine all of them together. So it is a bigger or a higher version of a diode. That device is called as a transistor. Like you can see in all these devices, all these photographs over here, looks like aliens to me. As if some new alien invasion has happened and these people are going to invade the earth, and maybe Will Smith is going to be there in that sci-fi movie. Anyways, so here these devices, do you see they have 3 legs? Why do you think they will have 3 legs? One will be for P, one will be for N, other will be for P. or it will be for N or P and then N. So one of these combinations. Do you get it? Why there are 3 terminals over here? Because each terminal is connected to one type of semiconductor, P or N. And depending on what order it is, there are 2 types of semiconductor transistors that we are going to study. Hello Sudarshanam, hello Niranjan, ready, welcome Bachalo. So let's understand what is a transistor exactly made of. So here is the construction of a transistor. It is a 3-terminal device. I think I can just put it over here. Okay, it is basically a 3-terminal device. It is a 3-terminal device. It is a 3-terminal device. That's a very important thing. So when there are 3 terminals, there are 3 semiconductors, different amount of doping that will be there. What do I mean by that? I will show it to you. Observe carefully. You take a big wafer. I'm pretty sure you have all eaten wafers, right? You might have all eaten wafers in your childhood. Chocolate wafer, strawberry wafer, like that. Here you take a wafer, but of what? Silicon. And you divide it into 3 parts. One part in the middle will be very, very thin. It will be very, very thin. This part is medium sized. This part is the largest. So this is basically the largest part, largest area. Okay. This one is basically the thin part or the thinnest area. All right. So this is something which you should realize. I have divided into 3 parts. Everybody with me? Okay. Now each of these terminals have a name. Now what is there here and here? I'll come to it. Hold on. The one which has medium area. This is medium area, not the biggest, not the smallest. That one is basically called as the emitter. This is generally having the symbol capital E. This is emitter. This is your emitter, generally used with the symbol E. The thinnest part is called as the base terminal. Okay, usually referred with the symbol B. And the largest area is basically called as the collector. The symbol for the collector terminal is C. So E, B and C. Emitter, base and collector. These are the 3 terminals which you saw over here. Emitter, base, collector. Emitter, base, collector. Emitter, base, collector. How do I know which is emitter, base or collector? Check the area. Biggest area, collect. So what does happen? Collect. So you are collecting. Imagine somebody who is a collector, somebody who is collecting a lot of money. What will he do? He will need a lot of space now. So he will have the largest area. That's how you can think of it. Thinnest one is the base. Base is exactly sandwiched in between. Think of it like the sauce or the cheese, or think of it like the cucumber, tomato, or whatever, patty, burger. You have a burger and this is like a sandwich, and there is something in between of that. That is the base, which is there exactly in between. Okay guys, I know your mouth is now started to water because I have started talking about food, and usually I do that. Anyways, the next thing is, what do you keep in these places? Either N type or P type. Either N type or P type. So for example, I dope this. Dope this means I adulterate it. I infiltrate it with some material which does not belong here, and I add pentavalent impurity. Pentavalent means 5 electrons. 4 electrons will form bonds with each of the silicon atoms around it. One here, one there, one here, one here. One extra electron which is there, that will be ready to mingle. So there will be extra electrons and you dope it. That means you add lots and lots of electrons over here. This is basically heavily doped. The emitter is basically heavily doped. In this case, I am putting electrons. I could have also put holes. It is now going to be a N-type semiconductor. This is a N-type semiconductor, correct? Because there are electrons over here, heavily doped with electrons. This one, collector, even though the area is large, you do not dope it so much. Just add few electrons here and there. Not so much as the emitter. Decent. This is moderately doped. This is moderately doped. Again, because you have added electrons, this is also N type of semiconductor. Everybody with me? Very nice. The last one is holes. Where will the holes be? Here. I'm going to put few holes here and there, maybe 3 atoms, or it's just a representation, don't take it literally. Very few trivalent atoms are here. This is the lightest doped. This is thinnest also and very least doped. So there is very less amount of doping. Least doped area is basically the base, and in this case it is P. So this device, which has a semiconductor which is N type on this side, N type on the other side, and P, which is the base on the middle, this is called as a NPN transistor. What is it called? NPN transistor. I could have done the other way around. I could have made this P, this N, and this P. So then it would be PNP transistor. Right now this is NPN transistor. Everybody understood this? There is a symbol for that. There is a symbol for that. What is the symbol for this transistor? Understand this. Show a circle. What do you do? Show a circle. Then show this line like this, and show one line here, show one line here, and show one line here. Now do you see that there are 3 terminals coming out of it? One terminal here, another terminal here, and the other terminal over here. Other terminal over here. Did you understand how I drew the symbol of the transistor? The one which is in middle, what am I going to call it, guys? Obviously, I'm going to label this as our base. I'm going to label this as the base. One of them is emitter, one of them is collector. You can choose whichever you want. Let's say this is emitter, and let's say this one is collector. Now you might be wondering, sir, how do I know from this symbol whether it is NPN or PNP? I'll just come to it. So guys, the fact of the matter is, whenever it is an NPN transistor, then from the base to the emitter, only in this part, you show an arrow mark outward. That means in that symbol, you are going to put an arrow mark between the emitter and the base in this particular direction. This is the symbol for a NPN transistor. This is the symbol for an NPN transistor. Everybody understood what is the symbol of the NPN transistor? Very good. NPN is the most commonly used. Most of the devices around you are NPN. Just keep on saying this, NPN. Very common, right? And what happens when something is very common? They're very easy to mingle. They are very extrovert. They are very outward. So that's how you are going to remember it is outward. PNP, nah, not so much. They are introverts. What are PNP? Introverts. So the arrow mark will be inside. That is the only change. So guys, if somebody asks you to draw the symbol of PNP transistor, draw a line, draw this. If you are using a rough book, just draw it. You will practice with me. Then what do you do? Take a line over here and then start marking the terminals. There is one terminal here, okay, and then there is one terminal here, and then there is one terminal over here. This one is obviously your base. This is, let's say, emitter. This is collector. Because it is PNP type, it is introvert, so inside. So this is PNP type of transistor. Everybody with me? Great. So what will be the only difference in a PNP transistor? I'll just show it to you over here. It will look something like this. Again, emitter will be medium area, base will be the smallest area. So if I show the terminals, this is emitter, this is your base, this is your collector. So for a PNP, there will be lots and lots of holes over here. Too many holes over here. This is P, okay, this is P type. Then here also there will be P type, but not so much, moderately doped. So this is also P, and the remaining electrons will be over here. So this is very lightly doped. So that is your N type. So PNP transistor. Everyone clear about this? Understood how the symbol construction, who is doped more, who is doped less? So guys, in your NEET exam, they are not going to ask very logical questions or very crazy electronics questions on transistors. They are going to keep it simple. very theoretical base, and this will also help you for your board exam. Write about PNP transistor, draw the symbol, show this, tell in words, this is thinnest, this is moderate, this is biggest, then this is heavily doped, this is moderately doped, this is least doped, this is a symbol, this arrow mark is outside. So when you write it neatly, you will get proper 3 marks or 4 marks. That's how it works for the boards. Otherwise for NEET, it will be purely theoretical. We'll be seeing some questions also. So transistor is formed by sandwiching thin layer of p-type or n-type between the another n-type or p-type of semiconductor. So this is NPN, this is PNP transistor. And I have put up the symbol in printed form as well, just for all of you. Now some of you will be like, sir, here emitter is below. Sir, is it wrong? Nothing is wrong. Even if emitter is below, no problem. Then show the arrow mark here. Don't put the arrow mark on collector. Put the arrow mark only on the emitter base, side. Only on the emitter base side, nothing else. Okay, so that was a printed material that you are going to also get in the PDF. Now is the next part, guys. Now is the next part. How do you connect 3 terminals to anything? How do you connect these 3 terminals to anything? So there are 3 different ways of connecting it, because most of the things around you, fan, bulb, AC, your fridge, your AC adapter, your mobile charger, how many pins does it have usually? How many pins does it have? 2, right? Take anything. Like the one charger over here, it has 2 pins. Like, sir, something has 3 also. Array, that 3 is for earthing. The third one is usually for earthing. Ignore that. That is just for safety. But all the devices around you have 2 terminals. Okay. Now, how do you connect a battery or a power supply or anything which has 2 terminals to a transistor which has 3 terminals? Transistor has 3, but your other things like battery, switches, etc. have 2 terminals. So what you do, out of these 3 terminals, you take 2 terminals, any 2, either emitter base or base collector or emitter collector, whatever, you take 2 of them and merge them together and then connect it. So you merge them. Whenever you merge them, that is called as making it common. What is it called? Making it common. So whenever out of the 3 terminals, you take 2 of them and connect a single wire to both these terminals, you have made it as common. It is common to this, common to that. So that's why it is called as common. Got it, everyone? So look at this now. Look at this first type. What I'm going to do, let me just show a transistor. It could be N-type, it could be P-type, really doesn't matter, guys. Okay, I'm just showing some random transistor. Okay, this is like this. Now what I do, I take this part. Okay, this is obviously base, this is emitter, okay, and this is collector. I take this collector and I split it into 2 parts, or rather these 2 parts are merging into the collector. One part I connect it to the circuit over here, maybe some devices are there here, and this part I connect it to other devices over here. Do you see the collector is split into 2 parts, or these 2 parts are merging at the collector? So what do I call it, guys? What do I call it? Collector is common. So that's why this way of connecting is called as common what? Collector. Common what? Collector. Everybody with me on this? Common collector, understood? What did I just do? I'm going to draw the circuit here, don't worry. There will be some battery or something like that, resistors, etc. But these 2 things are meeting at the collector and going inside it. So that's why common collector, guys. Everyone with me? Very nice. Similarly, again, let me just show another mode of connection. Okay, let me just show another mode of connection. Let's say like this. All right. So like this. Okay. Just take it out over here. This is your emitter, this is your base, this is your collector, correct? What I will do now, from emitter, I will split it into 2 parts, or rather these 2 parts are merging on the emitter. I will take one from here and the other from here. This is basically, just connected like this. Now, I will complete the circuit later on, don't worry about it. I have kept some blank part for a reason, you'll understand it. So do you see both these wires meet at the emitter? So the emitter is common to 2 things. So that is why this will be called as the common what? Emitter way of connecting it. Emitter is common. That's why common emitter. Everyone with me on this? The last part, the last way of connecting, guys, common collector, common emitter, what will be the last part? Come on, put it up in the chat box. Obviously, after collector, after emitter, the last part will be common base. So in that case, what you do is, let's say for example, again, let me show the circuit. Maybe I will prefer to show it like this. This will be easy. Okay, so again, I'll show the arrow mark like this, like this. This is emitter, this is collector, this is base. So I'll take the base common. So two circuits forming from here. So one from this side, one from this side. That's about it. So that is basically then called as the common base. What is it called? Common base. Everyone with me? Very good, GV. Very good, Deva. Come on, guys. Everybody participate. Next part is nothing but what exactly comes in these gaps. What comes in these gaps is remembered by this rule. Always remember this. The emitter base junction, emitter base is always going to be forward bias. Emitter base is going to be forward bias, and the collector base part is always going to be reverse biased. What is going to be there? Reverse bias for collector, and for forward bias it will be emitter base. Do you remember forward bias and reverse bias? Do you remember forward bias and reverse bias? Forward bias, current flow will be maximum. Current will be allowed to flow. P is connected to positive, N is connected to negative. Yes? Similarly, reverse bias, very small current will flow. Reverse current is negligible, hardly anything flows, it blocks. So N is connected to positive, P is connected to negative. So for making emitter base forward bias and collector base reverse bias, you accordingly connect some batteries or voltages. So you can connect some. So over here, collector base is reverse bias. I know over here, this is N type, this is P type, this is again N type. So base collector is reverse bias. So P should be connected to negative and N should be connected to positive. So this is what I'm going to connect. So this completes this part. Similarly, you can see that if I want emitter base to be forward bias, so N should be connected to negative and collector will be again at the positive side of this side. So that is how the functioning or the connection works for each of these configuration. So for each configuration, just you have to ensure emitter base is in forward bias. Just make sure emitter is connected to the negative part, and in collector base you will see that you have to keep it in the reverse bias. So if there is a P connected to negative and if there is an N connected to positive, that's how it works. Everyone understood? Very nice. So same thing I have put it up over here, all the three different configurations. This diagram might look little different than this, but actually give or take it is the same diagram, just drawn little bit neatly, nothing else, guys. You can see over here, this is common base. The base is common to circuits. Here this is common emitter. You can see the emitter is common to both the circuits. You can see over here, this is nothing but the collector which is common to both the circuits, so common collector mode. You will always see that the emitter base will be in forward bias and the collector base will be in reverse bias. Emitter base in forward bias, collector base in reverse bias. That is always the way to connect the transistor. Keep this in mind. This is the rule of thumb. Okay, so these three diagrams you can easily draw once you understand what is common and who is forward bias and who is reverse bias. Just take the example of even, let's say for example, this common emitter mode, or let's say common base mode. You can clearly see over here that in this case, this is N type, this is P type, this is N type. Notice emitter base should be forward bias, so N is connected to negative. N is connected to negative, and base collector is always reverse bias. reverse bias. So N is connected to positive. Do you see that? So that's how the terminals are decided, whether to connect it to positive or whether to connect it to negative. Good evening, Jeremiah Nikhila. Welcome, bacha log, join in. Here is the question for all of you. In a transistor, the width of emitter region is slightly more than of a collector region. Collector region is slightly more than of a emitter region. Emitter and collector regions are equal. Emitter and base regions are equal. Everybody should be able to answer this. Come on, guys. Many of you are asking me to conduct this class. So that's why I'm here to conduct this class. You have to show that energy. Or else then I will think that whenever you post a comment, it is all lies. You chumma ask me, sir, take this lecture, and then you don't attend, then it will be a problem, guys. So you have asked me to take this class, so that's why I'm here. Okay, everyone, B answer. Very good. You guys have been paying excellent attention to this lecture. Very good. Collector region is basically more than the emitter region. I just showed it to you over here in this particular diagram. Yes, you can see the collector had the largest area, but it is the emitter which has heavy doping. That means more number of electrons or holes are there in that region. Area wise, this is the highest. So that is the answer for that particular question. Next, which type of transistor is this? I am so happy. Sangeet Gautam, very good bacha, very good. You're a student from my last year batch. Which branch are you in bacha, and how is it going in VIT? I'm hoping it's going really great. And tell your juniors to attend all the classes and be sincere and just keep on doing the homework and practice lots of mock tests, right? So that's it. You are going to be in your college. Just enjoy your time, bacha. Good evening, Neha. Nice to see you over here. Okay, from NEET Made Easy to NEET English. B. Everybody B? Yes. What is happening? It's coming inside, right? If it is coming inside, introvert. Who is introvert? PNP. NPN, outrovert. PNP, introvert. NPN, outrovert. So, extrovert, sorry. So, that's how it works. So, NPN, it's always outside. PNP, it's always inside. That's the symbol for that. Very good. You nailed it. So, guys, let's move on to the working of a transistor. Let's see. Now, whenever this working comes, now many people get confused. Sir, how does this transistor exactly work? I did not understand it. What is happening? You should understand only the basic functionality of the transistor and how it works. That's more than enough. Don't complicate scenarios, because for NEET and board level, for you guys, very simplistic things are there. A transistor is more like a gate, is more like an amplifier for most of the applications. So think of it like this. Think of it like this. Do you see this water coming in? Do you see there is a canal over here? Do you see this lever arrangement is there? There is an obstruction. This lever is connected to this obstruction, correct? Okay. Do you see the water comes in from here? The water comes in from here. You might be thinking, sir, why is it sir talking about water and canal? What happened to transistor? Hold on, I'm coming to that. Okay, so there is water coming from here. The moment water comes, what will happen? This flap which is there, it will be pushed like this. This flap which is there, it will be pushed like this. Yes, Murthy, I teach in the crash courses and even the AI live courses, definitely. Okay, so guys, do you see the flap moving up like this? Correct? So when this flap just moves like this because of the force of the water, this is indirectly connected to this one. This is indirectly connected to this one. So as it moves, it rotates, it will make this go up. It will make this go up, correct? Do you see lot of water waiting to flow here? Lot of water waiting to flow from there to here. So the moment even little bit water comes here, it opens up the flap. The lever mechanism is opening this up, and the water which was waiting behind this obstruction is now let go, and this water both collect together and flow over here. This water and that water both flow together and lot of water will flow, correct? Yes or no? So guys, I teach in the English courses, Murthy. Yeah, not in the English, in the English, pure English. All my courses are in pure English. So my dear students, over here, even a small flow of water is regulating a large chunk of water to flow in this canal. So a small change is creating a big change over here, because even if this moves little bit, this goes up and lot of water was waiting there, a lot of flow will come on to this side. So this is actually how a transistor also behaves. So what happens in case of transistor is, replace this part with base, replace this part with collector, and replace this side with emitter. Base, collector, emitter. The flow, replace it with current. Small current, large current, both come together, becomes very large current. Small current, large current becomes a larger current. A small change in the current here, what is this? Base, creates a large change in the flow. It creates a large change in the flow of the current in the emitter or in the collector. So that's what you have to realize. So let me just start marking it over here. This is, now you can call it as the base. This one you can think of it like the collector, like I told you. And this one over here is nothing but the emitter. And the flow of water, that flow is nothing but your current flow. This is your current flow. This is basically small amount of current. This is creating a large amount of current. This is creating a large flow of current. Large flow of current. This is how you should visualize a transistor. Are you able to get it? Everyone with me? English, in Hindi there is a separate channel, cute videos. Yes, that's NEET Made Easy. This is pure English. You have Hindi English channel that's called NEET Made Easy, bacha. There also I am teaching. Everyone with me? Can we move ahead to the next part, bacha log? Can we move ahead to the next part, my dear warriors? Clear? Okay. Now how exactly a transistor works? Let's see from the electron perspective. It's not very difficult. Let's take the example of NPN. So there are lots and lots of electrons. So let me just put red dots for electrons. That's okay. This is emitter. So lot of doping will be there. Lot of doping will be there. That means lots and lots of electrons should be there over here. Okay. So that is what it means. Okay. Now this is collector, not so heavily doped, decently doped over here. Okay. So decent amount of doping over here. So that's how I will show the collector. And lastly, the holes on the P side, which is connected to the base. So very few amount of holes over here. Now let's take any type of configuration, really doesn't matter. Let's say for now, I'll just connect the base over here and this over here. But while connecting, I have to make sure that they are in forward or reverse bias. So I will just do one more thing, because emitter base is always in forward bias. In forward bias. So N will be connected to negative, P will be connected to positive. So I will just make a positive terminal over here. And this will be connected to the base. This will be connected to the negative side, because it has to be in the forward bias. Okay, so let me just connect it properly. Great. N is connected to negative, P is connected to positive. This is forward bias. On the other side, this should be reverse bias, because base collector is always in reverse bias. So P will be connected to negative. So connect this to negative, and this one is N, so connect it to the positive. That's all. That's all that you need to keep in mind. Everyone with me? Everybody with me? Why I did these connections? Now you will see the exact working principle of a transistor, guys. All of you were waiting for this. I know that. Now see what is going to happen. The moment this battery is connected over here, what will this negative terminal tell these electrons? To come towards it or to go away from it? Put it up in the chat box. Bharani, usually my live classes are at 9 o'clock or 7 o'clock. Sometimes I take it at other times in case there is an emergency like it was today. Whatever it is, I always put it up on the Telegram channel, so make sure you're a part of it. And also on the community, I post up the timetable. They will go away, right? Okay, so the negative terminal will ask these charges to go away. So what will happen? These charges, they will start going over here. They don't want to be near this negative terminal. So they are getting shooed away. They are getting shooed away. So these electrons will start going that side. Also, do you see these electrons want to come here because who is there? Holes are there. So these electrons would want to fill up these holes. Maybe they want to fill up these holes. So some of these electrons will just fill up these holes. But there is a problem, guys. There is a problem. GV, Yakub, Deva, everyone, Sanjay, Gokula, Libita, Niranjan, everybody, Navya, Vijay, everyone should tell me what is the problem. There are some holes here. There are these electrons here. What is the problem, my dear students? There is, I think, a small problem. What is the problem? Count the number of holes here. I think I have 1, 2, 3, 4. Very few number of holes. There are so many electrons. So what is the problem? Can all these electrons go meet these holes? No. This hole will say, this Champa will say, listen, I found this Pandu. This Champa will say, listen, I found the Pandu. This Champa will say, listen, I found the Pandu. This Champa will say, listen, I found the Pandu. What will all these other Pandus do? They will be like, I don't have Champa only. They don't have Champa. The moment, imagine this is like 100 Pandus finding 4 beautiful Champas. 100 Pandus finding 4 beautiful Champas. They will run towards those beautiful Pandus. Champas. These Pandus will run towards the beautiful Champas. But only few Champas are there. And because they are running with full speed, they are running like this. With full speed, they are running like this. By the time they realize, oh my God, all these Champas have found Pandus, they will be like, oh my God, they would have gone to the other side. They are running with full speed, no? They were going with full speed, no? Okay, so guys, you will see that because they were running with full speed, they will go on to the other side. Most of them. Few of them, some Pandus, they will be like, okay, listen, I have to apply the brake. Okay, I am very slow. Some Pandus will be very slow. No, they will not be able to run very fast. So some of these Pandus will go towards the positive side because this positive plate will attract few of the electrons. So very few of these electrons will just go over here. Everybody agreeing with this? Most of them will go to the other side because they were running with full speed. Very few of them will just go and enter these holes out there. Everyone out there understanding this point? Correcto? Yep. So these holes and these electrons, they will mingle over there, and most of these electrons are going to go to the other side. But you will be like, sir, there are more electrons here. Won't these electrons repel these electrons? Won't these electrons repel these electrons? Yes, you are right. These electrons won't like these electrons. These Pandus will be like, hey, why are these Pandus coming, man? I'm already here. Why are these Pandus coming? But don't worry. That is why this battery is there. What is this? Positive terminal. What will these electrons do? These electrons would love to go towards the positive terminal. So you will see these electrons will basically flow towards this positive terminal. They make space. For the newer Pandus. Understood? So these Pandus like, okay, let them come, do whatever you want. I am going towards that side. They will run from here, and they will go towards the positive terminal. Yes or no? And that will make space. Then when these Pandus come, these Pandus will get attracted over here. But obviously these electrons are not just going to stay here. They are going to continue their journey like this. All these electrons will pass through this battery, and they will again flow back from here. So this is how that journey begins and continues forever. So understand, these electrons which first left, and some of them met the holes, some of them, maybe the weaker ones, the slower ones, just went to this guy. Most of them energetic, but could not meet the holes, go to the other side. And the advantage was this was very thin. Because it was very thin, they can easily cross over to the other side. You will see that by the time they reach here, these electrons would have gone here. These electrons would have some space, and these electrons along with these electrons flow together towards this side. They will replenish Meaning, because these electrons had already left, they will be recovered by the new supply of the electrons. Again, new supply of electrons will come. Some of it will go here, most of it will go there. Again, they will meet and again go here. Again, they will come like this and again come over here. Are you able to visualize this in your head? Are you able to visualize this in your head? Hello, Mahalakshmi. If you have been able to visualize, give a thumbs up, guys. That's all I need from you. So, my dear students, if I show the current will be exactly opposite, no? Because these are electrons. These are nothing but your flow of electrons. Current, conventional direction is opposite to the flow of electrons. So guys, if I show the current, basically N is connected to negative, okay. If I show basically the current, how will the current look like? The current will be exactly opposite. So if it is going in from here, I should show the current coming out of it like this, If electrons are coming out from here, I should show that it is going in like this, correct? Okay, this is all arrow marks this way. And over here, if it was coming out from there, so I should show it going in. So that means like this over here, Everybody gets it? So this current which is coming out of emitter, I will call it as emitter current. The current which is going inside the base, I will call it as the base current. The current which is going over here through the collector, I will call it as the collector current. Everybody gets this? Very nice. Now you only think properly and tell me, emitter current comes here, splits. This is a junction. And whenever I have a junction, I think I can use Kirchhoff's current law. Use Kirchhoff's current law and quickly put it up in the chat box. Which current is which current plus which current? Quickly think and tell me. This current comes like this, goes like that, and again comes over here, and again comes like this, and goes here. Come on guys, quickly think and tell me. Which current is which current plus which current? Which current is which current plus which current, guys? Obviously, it's the emitter current which splits into two. The emitter current, this is the emitter current, which splits into base current and the collector current. So IE will be equal to IB plus IC. This is the final formula that you get. Everyone with me? Excellent, guys. Very good, Yakub. Very good. No problem, Anish. Watch from the start or else you will not understand much. No problem, Anish. I have an emergency. I have to go now to the doctor. So that's the reason why I had preponed my class. Okay. Correct, everyone? Awesome. Do you think base current will be more or collector current will be more? Well, if you're not able to answer it, no problem. Look at this diagram and tell me base current is more or collector current is more. Quickly put it up in the chat box. Look at this. Few electrons, very weak electrons will come from here. Most of the electrons are going from here and coming here. So there is large flow of current through the collector. Base has negligible flow. So the collector is higher. So the collector flow is higher. So can I say the collector flow is much higher than the base current? Base current is negligible. Therefore, can I say emitter current is almost equal to the collector current? Almost, because base will be, if it is microamperes, this might be milliamperes. Milli is much larger. This will be very small as compared to this. So that is the reason for that. Very good, guys. You guys are very smart, yeah. Very smart. Now, whenever you have a transistor, now you have two important parameters which you should be aware of. There are two important parameters which you should be aware of. These currents, apart from this current law, there is one more relationship between them. Every transistor has two parameters. Like you have your weight, you have your height, you have your color, you have your size, your arm length. So many parameters are there for a human being. Your eye color, hair length. Same way, transistor also has alpha and beta. These are the two important parameters of a transistor. So what are these parameters, alpha and beta? It is nothing but the ratio of the currents. Whose ratio? Always remember, collector. Do you know collector is a very important government position? Like you have IAS officer, you have Tahsildars, you have IPS officer, you have commissioner, right? Hello Roshni Konki, no problem, just join in bacha log. Similarly, there is a collector. Collector is a very powerful position, powerful government position, guys. So collector, where will he sit? He's a powerful guy, right? Will he sit on the top or will he sit at the bottom? Will he sit at the top or will he sit at the bottom, guys? Come on, put it up in the chat box. Will he sit at the top or will he sit at the bottom? Collector, powerful. He will sit at the top, right? So where will you put the collector? Collector current, you are going to put it on the top. Collector, you are going to put it on the top. Simple, very nice. Now collector is done. Only two symbols are remaining. Emitter and base. Emitter and base. Does alpha or beta resemble to E or B? Symbol, that symbol, alphabet. E, B, alpha, beta. I can see beta and B are similar. Beta and B are similar. So guys, for beta, you are going to put the base current. Similar symbols, na? Very similar symbols. So what will be left over here? Emitter. That's it. Emitter current. These are the parameters of a transistor. Alpha and beta. If you know alpha, you can find beta. If you know beta, you can find alpha, guys. Because this and this together can give you the other one. Understood? So simple it is to remember these parameters. So many students get confused otherwise. So this is the easy trick I have given you because you have attended my class. Okay. Now tell me, guys, will alpha be more than 1, less than 1? What do you think? Think logically. Emitter is the largest current. It is slightly larger than the collector. So alpha, think collector will be smaller. Numerator will be smaller than the denominator. So it will be definitely less than 1, but it will not be so less, like 0.5, 0.6. It will be generally, what will alpha be? Alpha be very close to 1. Close to 1, like 0.9, 0.99, 0.95. Correct. Because 95%, 99%, 92%, 90%, like that. Okay, great. Similarly, can you think what will beta be? Will it be more than 1 or less than 1? Think carefully, guys. Collector current is much larger than base. So numerator is bigger than the denominator. So numerator is big, denominator is small. So the ratio will be much larger than 1. Very good. So I just got that alpha is less than 1 and beta will be more than 1. Perfecto. So on the Vedantu NEET English channel, maybe not now because electromagnetic waves not so high weightage topics like I have promised you guys. First high weightage, most important topics, like I had made the session, the most important topics for your NEET examination. I'm going to follow those topics only first, 11th, 12th mix, and then we'll go to moderate weightage and then to maybe low weightage. So always from high weightage to low weightage, guys. So I have put up all these things over here. So IE is IB plus IC, alpha is nothing but IC by IE, beta is nothing but IC by IB, and you can convert this from one another. So this you can easily get using this and this relationship. Should you remember this? I don't think so. Why you should not remember? Because it is confusing. If you know this and this formula, you can convert from here to here or from here to here. I'll be doing a problem like that. Okay. Now, what is the important thing that you learnt over here? Base current is small. The emitter and the collector current are large. So imagine if somebody makes a small change in the base current. Won't there be a large change in the collector current? You trigger somebody something. You tell, hey man, you are a fool. That person will get angry. He will become like Hulk. He will turn green. And he will start shouting. He will start throwing things. That's it. He will become very angry. So a small trigger here creates a large change here. So that can be an application. That's exactly what was happening in this water. A small current was creating a large flow. Sometimes it happens, no? Some people do that. So that is basically an amplifier. What is amplifier? Amplify. You give me small thing, I'll give you large thing. You give me 1 rupee, I will give you 10 rupees. You show me little bit of love, I will give you so much of love, guys. I'll give you so many lectures that your marks will go up the roof. That's all I ask now. One small like, one small subscribe, one small beautiful comment after the session is over. Sir, I attended your class. How much happy the teacher will be. That's all. I will give you many things. I'll give you many lectures. I'll give you all my knowledge over here. Thank you, Neha. Thank you, Jolene. Thank you so much. Put it up in the comments also later on. So guys, that is what an amplifier does. Do you see over here? There is a signal up and down. AC signal, DC signal, whatever. This is the input. Why is it an input? Maybe there is some noise coming from somewhere. It is not very large. Small faint noise is coming. Faint sound is coming. I want to hear what are they saying. So I put an amplifier. I'm pretty sure you would have seen an amplifier in your speaker system, sound system, music system. You turn up the volume, the sound becomes large, or you hold a mic, it is connected to the amplifier. It amplifies the sound and the entire audience can hear it. That's exactly the job of an amplifier. Nothing else. So some signal is coming. Where is it entering? Look at this carefully. Where is it entering? Base, right? It is entering the base, right? And do you see that the current will, here you can see there is a speaker. Where is the speaker connected? To the collector, right? So a small change here will create a large change here. A small current will create a large current here. Input is small, output is large. So it has amplified. It has amplified the current. That's all, guys. So here, if I ask you the current gain, it will be output upon input, output current upon input current. Can you guys quickly think what is the output current? The output is near, the speaker is connected. Where is it connected? Near the collector. So IC. Input is near the base, so it is IB. So IC by IB, whether it is alpha or beta, obviously it is beta. Obviously it is beta, guys. How it amplifies? That's exactly K. Bharat. I explained the working principle of a transistor, right? Small electrons, few electrons flow here, many electrons flow here. So any small change here creates a large change here because this ratio is constant. This current by this current is constant. That is exactly the parameter. That is exactly the parameter IC by IB. So if base changes little bit, IC has to change by a large amount. Correct? Because the ratio has to be constant. Understood, KP Bharat, Vikram? Understood? So if base increases by few milliamperes, collector has to increase by large milliamperes. That is the logic behind it. So that's how it is able to amplify in the first place. But this is okay if there is a constant current. That means it is DC signal. What if it is AC? Then if it is AC signal, then what will you do? This current will not be constant, it will be varying. So the changes in the AC current of the collector upon changes in the base current of the AC signal. So this will be the beta value for DC and this will be the beta value for AC signal. Why this delta? Because in AC the current will keep changing up and down, variations will be there. So you take the changes in the current or for varying current. Everybody got it till here? Output by input, that is nothing but your beta for an amplifier. So this much is done, this much is done, everyone? Okay, last thing is nothing but called as the voltage gain. Voltage gain is output voltage upon input voltage. Now can you think over here what is the output voltage? Can you think over here what is the output voltage? V is IR, Ohm's law. Voltage is current into resistance. Current over here is basically IC. Current over here is IC. Maybe there is some resistance over here. So into the resistance near the collector, IC into RC. Correct, guys? And upon input voltage, input voltage, do you see the current over here is IB, and there might be some resistance over here near the base, so it is basically RB, guys. It is basically RB, correct? So that is nothing but your gain in the voltage. Sometimes this is also just called as, see, over here whatever voltage is coming, this is called as output voltage. So it is IC into RC, and this is input voltage, which is then called as IB into RB. So V out upon V in. That's exactly what it is called. Clear-o? Understood-o? In fact, IC by IB is nothing but beta. You can also call this as beta if you want to. IC by IB is nothing but beta. That's also okay. Great. So all these things I have put it up over here also in the printed form, but in case you wanted it in my handwritten notes, that is there over here. So that was transistor as an amplifier. Thank you so much, Nia. I think it is clear-o, amazing-o. Let's try to solve some questions. NPN transistor is biased to work as an amplifier. Which of the following statement is not correct? Which of the following statements is not correct in a NPN transistor? Just draw an NPN transistor. I have given you the diagram also. Just think, where does the electron flow or the holes flow, whatever. You will immediately get to know which of them is not correct. Which of them is not correct? Electrons go from base to collector. Electrons go from emitter to base. Electrons go from collector region to base. Or the conduction in the transistor is due to electrons. I think one of them is definitely wrong. I can clearly see it. Let's see whether you guys are able to identify what is wrong. In case you have forgotten which diagram to refer to this diagram. This is the working of the transistor, which I just explained some time back. So just use this diagram and think what is wrong in this particular statement that I have given. A lot of you are saying C, some of you are saying even A option. The correct answer is indeed C. Electrons go from base to collector. Perfect. Electrons do go from base to collector. Do you see that over here? From base to collector. From base to collector. Do you see? They go from emitter to base to collector. Perfect. That is correct answer. That is definitely correct. There is nothing wrong. Electrons go from emitter to base. Yes. They go from emitter to base to collector. Some electrons might directly jump over here also. That's perfectly correct. Electrons go from collector to base. Definitely wrong. Conduction is due to electrons. That is wrong. It is due to electrons. What am I saying? Conduction in the transistor is due to electrons. Yes, the electrons are the ones which keep flowing like this. The base collects, gives the electrons, and it is supplied to the emitter. So the base current plus the collector current is the emitter current. So the flow of the electrons is what gives you the conduction. Right? So all these options are correct, and C option is definitely wrong. Moving on to another question coming up on your screen, guys. For a transistor, the base current is 2 milliamperes. Collector current is 18 milliamperes. The parameters are alpha, beta. And what is the emitter current? Beautiful question. Yes, acing, I will try to do something like that only, but I will first do high priority topics first. High priority. I will be doing circular motion, don't worry. But I will do it in a very peculiar way which you will like. Don't worry. So guys, I know over here the base current is 2 milliamperes. I know that the collector current is nothing but 18 milliamperes. I know one thing, that the emitter current is nothing but the base current plus the collector current. So base current is 2, collector current is 18. So this will be 20 milliamperes. That is your emitter current. That is your emitter current, correct? So I got this answer. Very nice. Now what are the next things that we have to find? Alpha and beta. Alpha is IC by IE. IC by IE. Okay. Collector current is 18. Emitter current is nothing but 20. If you want, you can keep it as 9 by 10. Correct? 9 by 10, which is nothing but 0.9. So alpha is nothing but 0.9. That's what we got. Last thing, beta. Beta. What will you do, my dear students? It is IC by IB. B beta, right? Collector is nothing but 18. Base is nothing but 2. So 18 by 2, that is going to be 9. So that is your beta. And I had told you beta is always more than 1, alpha is always less than 1. So that is the relationship. Excellente. Excellente. IC by IB, that's 9, and alpha is nothing but 0.9. That's what we got. Yep, excellent guys. Proud of all of you. Nice to see all your answers. Let's do one more question. Let's see how many of you can do this. The beta is given to be 100, then alpha will be, wow, beta to alpha conversion. Beta is given, then how much will alpha be? Okay guys, let's take example only and do this. Beta of a transistor is 100. Beta means collector by base current is basically 100. So collector current is 100 times the base current, correct? Great. Now the emitter current, which is base current plus the collector current, instead of IC, I can write it as, instead of IC, what can I write it as? I can write it as 100 times IB. So this will be nothing but 101 times IB. That is what I get IE as. That is what I get IE as. Okay. Now what has been asked? What has been asked? The question is find alpha, right? Alpha is collector by emitter. Collector by emitter. What is collector? 100 times. 100 times IB. What is emitter? Emitter is 101 times IB, correct? So IB cancels, so it will become 100 by 101. 100 by 101. What will this be? Approximately 0.99. Approximately be 0.99. Excellent. That is the answer. You can see that. 0.99. Isn't it simple? So I had told you some time back, do you really have to remember this formula? Alpha to beta, beta to alpha? No, right? What did I tell you? Just remembering these three, it is enough to solve the question. So if you look at the solution also, right, it has some conversion formula. A lot of people get confused. Don't remember. Just do it normally. Beta is this, alpha is this, IE is IB plus IC. So this is one important step, and this is another important step, and this is another important step. 3 equations, I got it. Perfecto. So guys, that was your transistors. You have learned it from the NEET perspective, also going to be helpful for your board preparation. Join the Telegram channel so that you get the entire PDF with my handwritten notes and the questions. Make sure you join it so that you also get updates. And please leave a comment after the session is over saying semiconductors done. Done, sir. Waiting for the next chapter. Just put it up in the comment section. I'm waiting to see all your comments. Okay. That's only way I get motivation to conduct more classes for all of you. Thank you very much. Stay subscribed. Stay tuned for the next session. Have a great time. See you again tomorrow at 9 o'clock. Bye bye. Hasta la vista. This is Captain Shreyas and I'm signing off.